Hi students, in this session we are going to discuss chemical properties of aldehydes and ketones. Aldehydes are more reactive than ketones, I already told in the first session. So they are going nucleophilic addition reaction due to electric and electronic resonance. So here we just look over the nucleophilic substitution. Here these are both for aldehyde as well as here it may RH or else RR, whatever it may, these both are undergo reaction similarly, either aldehyde or ketone. So the substitution is based on that. So cyanide is substituted his cyanohydrin is formed like this. Adduct of cyanohydrin is formed. Again here sodium sulfonic acid, sodium SO3Na is added here, H is joined with this nucleophilic substitution OH like this. Then Grignard reagent, this is also like this, the R is added here, then OH is released like this after the hydrolysis. Then aldehydes reacts with alcohols, it gives acetol. Then ketones reacts with alcohol, they give ketol. Hydrazine, if the Z, we generally call this is a Z group, this Z may be an alkyl or aryl or NH2. If it is NH2, no hydrazine, otherwise OH hydroxylamine or NHC6H5, phenyl hydrazine, like that lot of substitution is there, or else amide. If whatever it may, here just removal of water, the C double bond N is formed based on, we called as some skiff bases. So this form like the C double bond N bond is formed by the removal of water molecule. This is general for these are all the substitution instead of Z. So then aldol condensation, this is a very known name reaction. If it has a condensation of aldehydes and as well as ketones having at least one alpha hydrogen. Carbonyl attained group near the group is if contain hydrogen, that is known as alpha hydrogen. This carbon is alpha carbon. If it contain hydrogen, that is alpha hydrogen. So here 3-hydroxy derivative is formed in presence of base. Here 2 moles of acetaldehyde undergo reaction, it forms 3-hydroxy derivative followed by we have to remove the HOH, that is by the dehydration it form alpha beta unsaturated acid, students. Then Cannizzaro reaction, if aldehydes does not have alpha hydrogen, means they are undergo self oxidation and reduction. That is both oxidation and reduction happening in the same species. Here formaldehyde I am choosing, there is no alpha hydrogen. So it reacts with concentrated potassium hydroxide. One undergo formation of alcohol, another one is form of salt of acid. Okay, potassium salt of acid form here. Crashed Cannizzaro reaction. Here one is benzaldehyde. This is also does not contain alpha hydrogen, and one more is formaldehyde. This forms a benzyl alcohol and sodium salt of sodium formate. It is formed. So again Glammenschen reduction, here amalgamated zinc in presence of hydrochloric acid, it undergo conversion of CO group. This carbonyl group is converted into methylene group CH2. So alkane is formed. These both only the reagents are differ but the products are same. When we convert aldehydes or ketones into respective alkane, the carbonyl group is CO is converted into CH2. Here this is Wolff-Kishner reduction. Hydrazine in presence of base in ethylene glycol, this will give alkane. These are all both are having same products like that, but the reagents are different, students. Based on the reagent, we classify the name as Glammenschen and Wolff-Kishner. Hydrazine for Wolff-Kishner. When aldehydes and ketones are undergo oxidation, here I represent R is maybe H or alkyl or aryl, whatever it may. The carbonyl group undergo oxidation like this. When it undergoes strong oxidizing agent, the aldehyde ketones are converted into acids, carboxylic acids. Then these are the chemical distinguishing test oxidizing agents. One is silver nitrate, that is ammoniated silver, that is silver mirror tolerance reagent we generally known as. When it undergo tolerance reagent, we get silver mirror image by the precipitate of Ag. If it undergo reaction with Felling solution, again it give red precipitate. If it undergo Benedict solution, that is copper oxide or copper hydroxide from sodium citrate, in presence of sodium citrate, that also give red precipitate. These are all the chemical distinguishing test concept, you have to more concentrate in this, how to distinguish aldehydes and ketones like that. So it undergo respective precipitates and mirror images. We have a positive test for silver mirror image and Fehling solution positive when it red precipitate is obtained like that. Aldehyde give positive test with Tollens reagent, Benedict reagent and Fehling solution, while ketones do not give such test. So this is the distinction. I already told no how we have to distinguish aldehydes and ketones. So with this here sodium OX is there. The X may be chlorine or bromine, whatever it may. Here the ketones undergo reaction. It forms like this. This form haloform reaction. Thank you, students.